So I think since we do have a few new faces and we actually can't see the guests joining us virtually, let's just go around the room real quick and give an introduction of who's in the room. I will start off. My name is Mike Byer. I am a board member on the Housing Authority and co-chair of this infrastructure committee. And now I'll pass it off to Webb here.
Webb Jones, I'm the co-chair with Mike. I'm a member of the steering committee.
Ryan Spastat with Landmark Consultants, we're part of the design team.
Paul Looney with the Yampa Valley Sustainability Council.
Catherine Titus, interested citizen.
Emily Katzman, staff of the Housing Authority.
Oh, Dylan Anderson with the Steamboat Town today. I'm Jason Beasley with the Housing Authority.
And I'm Brooks Kellogg, also an interested resident, and I've been building here since 1972.
And can our online folks unmute? And just say a quick hello.
Mike Morty with Route County Road and Bridge.
Thanks,
John
Mike.
Snyder with Steamboat Springs Public Works.
See you, John.
John Spezia, citizen at large or small.
Welcome, John.
Jai Carroll here with City of Steamboat Springs Public Works.
Tim Sullivan with Yampa Valley Sustainability Council.
Virginia, do you want to just you're the final person of just saying a quick hello and hi and who you are, introduce yourself.
Virginia Herman with YVEA. Hi.
All right, great. One little bit before we get over to Paul, one little bit of housekeeping I did want to bring up today. We all saw that article in the paper the other day, and I actually had a burger with a friend last night, and he was like, "Hey, what's going on with the comment about YVA can only provide 15 more houses to people in the county?" I'm like, well, that's not quite the whole story, and we're working on that, cleaning it up. But I think I do want to give Virginia a minute or two to kind of clear that up. But I think something that all of these teams and our amazing community outreach regarding these sessions and group focus meetings is that we do want to try and make sure that we're as accurate as we can be in those things and not affect businesses and other people in potentially a negative way. We're all trying to give the best information we can. We're sometimes making assumptions and putting things ahead of the cart ahead of the horse. And we really want to try and minimize those impacts that might be our community members or businesses. So I do want to give Virginia just a minute or two before Paul gets going to just kind of give that insight. And I think that actually falls to all of these infrastructure groups that none of what we say can be provided, water, storm drainage, happens just without nothing else happening. So Virginia, if you want to have a second to.
Thanks, Mike. I appreciate that. Yeah, I saw the paper article, and I've talked to Jason, and I think we are all on the same page. But I just wanted to clarify that we don't have an issue where we can only serve 15 more homes outside of city limits. That is in no way accurate or true at all. At this specific location for Brown Ranch, we were asked to provide, if we had to do it today with no infrastructure upgrades whatsoever, how many homes could you serve today? That would be 15-ish, but even then that's a guess, right? These are all guesses. We can serve thousands with infrastructure upgrades, just like water, right? Just like any other utility. We are not out of power. There's no limit to us being able to build new houses in the county because of YVEA. We do have the ability to serve more load in this county and in Moffett County as well. So I just wanted to clarify that's definitely not the case. And Mike told me that he had dinner with his friend last night. He's like, so only 50 more houses in the county. No, not true. So I do appreciate giving me the chance to clarify that.
Yeah, thanks. It was interesting too. My first out in the community with a friend, we just started talking about the newspaper article. I'm like, what did you think of it? And his first comment was, it sounds like YBA is out of power. I was like, oh no.
You're not out of power. You're not out of power.
So, great.
The other thing I like to add to what you said, Mike, is all of these things, not just energy, these are all very complex things. And we're trying to distill them down to a 1 hour meeting.
Yeah,
And we're gonna spend the project will spend the next several years continuing to research these and find solutions and,
yeah.
make a successful project.
I appreciate it. And I appreciate how kind of forthcoming the city with the water conversations, like everybody's making a lot of assumptions and we're trying to all push this ball forward and get in a good spot and understand our, our pinch points, et cetera. So thank you to everybody and just want to make sure. Yes, Kathleen.
In that article, there was also an interesting comment that we might consider an independent mini grid within the development. Is this the place where that gets discussed and has it been discussed?
I think that could be part of Paul's comments
It
today.
hasn't, so.
So I think without further ado, let's hand it over to Paul and continue on with his presentation from last time.
Okay, so I'm not gonna regress to what we discussed last time, but I'll call this meeting 4B or
Yeah, that's great.
5A, I don't care which, but we
Yeah,
kind of ran out of time.
perfect.
So I do want to take you back to the original template for the last meeting. So these were the questions we were gonna finish answering at meeting 4. So to your point, what energy options should be considered? And there's two kinds of energy options. There's building energy, and then there's the site energy. So we have part of that conversation last meeting. We'll have the other part of that starting with this meeting. What precedent projects should be considered as models for Brown Ranch? So I'll go over a really nice precedent project that y'all can consider. And then the last one, which goes into all of those discussions, is how do investments involve the phasing, which is to Virginia's point, we can't get there today, but what would it cost and how long will it take? And if we did another option, what would that cost and how long would it take? So with that, you can jump past the 2 slides we got through the last time. So that was a great tee-up question. What energy options should be considered for the Brown Ranch? So again, as I did last week, just a little decision tree to kind of help keep it in focus. You really have 2 choices. Your 100% grid tied, which is, we'll call that the business as usual or traditional system, right? And that's where we heard last week on how much load can be served from the new substation or upgrade to the existing substation at the airport. If the load gets too big for that existing substation, then there'll be another cost point to go further back in the system to where that substation gets its electricity from Excel. So that was pretty much, I think, what we heard last time, and what we'll need to fine tune is YVEA, and I used to be a utility planner, they can't size a system until we tell them what the load is. So once we dial in the load, then they can sharpen their pencil and say, okay, we don't need to upgrade past the substation, or we do, and here's how much it's going to cost to get from the substation to Brown Ranch. And then the last piece is, once you get to Brown Ranch with the primary service, you still have to get power to each building. So then there's a cost point for that infrastructure. So we're way too early in the conversation for that, but I think we should frame our discussion on how much power are we going to use? How much is it going to cost to get there with or without the need to upgrade the feeder to this new substation? And then what's it going to cost to distribute that power once the urban group has given their densities and their linear footages and their KWs per home? So just stop there for a second. If there's any questions on that side of the decision tree, which 100% grid supplied, we're going to go through a conventional design and costing process. Okay, that went faster than I thought. The only other option really is, are you going to do everything on site? So that's what the paper mentioned. We just need to throw that out for the conversation. Well, that leads to another decision tree that says, okay, well, if you're going to do that, the heating loads of this project are going to be the single biggest driver of the total energy footprint. And in Steamboat, the heating loads tend to occur when we have the shortest daylight. So if solar was an option, you'd have to size for not only the energy you use during the day, but you'd have to somehow have energy in a battery or auxiliary generation system or whatever. So a standalone island microgrid has to design not only for what's going on when the sun's shining, but how do you get through a 5-day storm when there is no sun? And again, that's driven by what's your total energy need, what's the first cost of that system, what are the operating costs, what's the life cycle. And then the third option is sort of a hybrid, which is really just mashing the two, which is you can have solar generation on site, you can have batteries on site, and you can also connect to the grid. And so that's a third kind of analysis point that says, well, can we use batteries to supplement the biggest size? And then that goes to YBA, and they say, well, if you guarantee us your peak load's not going to exceed this, then we can get to your site for this much money. And if we have to design for the ultimate peak and those batteries and solar systems don't impact that, then that's another cost. So really it's, you know, it's all or nothing or a hybrid, and each one of those paths have their own costs, life cycle costing, decision points, and those kinds of things. So just wanted to go through that. And then the bullet points up here are just kind of, what does a non-traditional grid look like? And then starting with that is what Virginia did with shared with us last week, right? We know the grid's going to be more carbon free because there's a state statute that says it has to be 80% carbon free. And we know that YBA's current power supplier has an aspirational goal to be 100% carbon free by 2050. So the energy decision to have a microgrid or not is not going to be a carbon-based decision. It may be a first cost decision, it may be a life cycle cost decision, but it's not a carbon decision, if that makes sense. Okay. And then to get to the hybrid model, then that leads to a potential path, which is you have a master metered community where YBA delivers power to a point at Brown Ranch, and then Brown Ranch does whatever they need to do internally from there. So those are called master metered communities. And then the other option is that standalone microgrid where everything happens within the confines of the property. And then there's all kinds of choices that go into all of those, which are battery storage. You can also use a traditional system, but put solar on every building or part of the buildings to offset the grid power. And again, that would be, I think, an economic decision more than a carbon decision, because few things are certain, but we do know by state statute, grid power is going to have a much lower carbon footprint in the future than it has today. And then from there, you can go into all kinds of rabbit holes. You can buy green energy offsets. So you could have 100% carbon-free power the first time the lights come on. You can have this, as we talked before, your choice in heating, your backbone heating system. So an interconnected geothermal energy system will reduce both the sizing of the electric system and the kilowatt hour consumption. That gets you closer to being able to offset your energy on site, or most of your energy on site. Tim's on the call, so we'll put this out there because he usually yells at us when we do. You could burn wood on the site, right? You could have a wood burning cogeneration plant that makes electricity, gets rid of dead trees, and also puts thermal energy into your common thermal system so that you're harvesting electricity and heat at the same time. You could do the same thing with a micro turbine. So you have if you don't do a gas connection, you can have a big propane tank. And now 5 days out of the year when there's not enough sunshine, you can burn propane, make all the electricity that solar can't make, and dump that heat back into your system. So, and then you could maybe sign a contract. There's the new models for microgrids. So there's companies that show up and they say, hey, we'll build it, we'll maintain it, and we'll charge you a monthly fee. So there's all of those layers of the onion that need their own analysis if you decide to take that look even. And I think that's part of what this committee and other committees are going to do, is how far do we want to skin the onion. So when you do that analysis, you've got to look at first cost versus lifetime cost. So again, where does the money come from? Well, right now we know that connect to the grid, the money's going to come from the housing authority. Well, maybe somebody's willing to put up the money to not to have an island. You just need to do that analysis. What are the sustainability goals? And so then we get into some conflicts. If the one sustainability goal is to be 100% energy independent, how many acres of land does that take out of production to do that? So then you suddenly gotta, if you're gonna go total PV, that's gonna consume acreage. And is there enough acreage to do that? And that kind of thing. And then it goes to the timing. So not only do you have to have your planning, your permitting, and your construction, does one path happen faster than another? Is one path more flexible than another? So you have to look at the whole timing. And then you also have to look at what are you going to do in the future, the commitment to individual building systems. So maybe another hybrid answer is connect to the grid, like I said, and have self-generation on individual buildings. And you could then build those buildings so over the course of a year, they are net zero energy consumption. So many, many points to discuss there. And that's, like we just said, Mike, that's why it's going to take some time to pick a path or two, do those side-by-side analyses and see which answer comes out as the winner. So, and what we know for today is today's energy prices, today's meter fees, and then we'll soon have prices to actually connect to the grid that can be compared to other energy sources. So it's a lot to talk about on one slide, but it's also a lot for this group and others to digest. And we could stop and kind of think about it or take questions or keep punching along on our time frame.
Well, I'm curious as to the complexity of these systems you're talking about. And if I understand Yampa Valley Electric's position, is they don't want to be overloaded. And these systems you're talking about with their complexity and novelty, I just wonder if Yampa Valley would say, we just cannot take that risk. We're going to build to the load that we anticipate, anticipating the day that we can't shed load. And Virginia, maybe I'm missing the mark there, but you guys have to be.
We have to build for the peak demand. We have to size our system for the peak demand if you want to be grid connected. So,
whether or not there's some supplemental source.
right. So if you did the hybrid option, you would have to build to the peak anticipated demand for the subdivision, just like you would if you were doing the fully 100% grid type.
So just as if the hybrid tools were not in existence.
Yeah, it's really hard. I mean, I guess show me the hybrid proposal and what that does to the demand, and then we would build it to the demand that you guys give us, right? But we can't take it and say, well, because you've got solar from these hours to these hours, we don't have to build this extra feeder. That's just not. I mean, otherwise you risk not having power at certain times, and that's not how we build electrical grid. So yeah, you would build to the peak demand.
And to echo that, she's right, because your peak demand is going to be heat driven with EV charging when there's no sun
When there's no sun.
and it's cold.
Yep.
So
you
why
have
are we talking about all this woo stuff?
Well, so the other option. So what we don't know is how many KVA does business as usual? How much does that cost to build to that 1 day or 2 day or 3 day peak? And then what if you had a bank of batteries on site, right? Or maybe they could own the batteries that said, okay, now we got enough battery to get through those peak hours and recharge, or get through that peak week and recharge. And then did that drop the construction cost? So the pipe to serve the community shrinks, and it costs less to shrink the pipe over here than it does to build the pipe over here.
You know, my head is spinning, and fortunately, it's not our decision. We're collecting data. We're going to rely on you and sustainability focus team and other experts to throw all that in the blender and see what makes the most sense. That's my impression.
It does seem to me as well, though, when we look at these options, and we know that one of our top factors is cost, that the hybrid model seems to not be very attractive since we're paying the same amount to be grid tied. So really, it seems like the two options are being grid tied or no grid tie. That seems like the two that are potentially out there. I can't imagine that with everything that Virginia Paul said about eventually the grid itself is going to be much cleaner. Why would we invest in those other pieces with a grid tie? I can't see the benefit of doing that. Maybe there is an answer that someone else sees, but I can't. So I think those are the two that we want to look at.
Couple things, when you didn't discuss putting in a fluoride water system at the dump as another source of offsite energy. But I think what we should be looking at is the long-term cost of supplying energy. That's the real cost. The front-end cost, whether you do a hybrid or just do a straight electric, that's a funding problem in front. But beyond that, whatever decision you end up with, what you really, I think, long-term need to focus on is the cost of using electricity. Whatever we think the meter says now, we know 50 years from now, it's going to be a different number. And if we're able to reduce the actual usage through smart building systems and alternative or hybrid sources of energy, and maybe we build a solar farm in Craig or something and put it into the grid there rather than use up our limited amount of real estate. I know for most people trying to start a project, the front end cost just blows them away. And this isn't any different. This has got a huge amount of front end cost because you've got a dry site. But if the purpose of all this planning is to plan for long-term function, to keep it affordable, we can't ignore the systems that will keep our costs down long-term.
So yeah, it's a multivariate equation. First cost, life cycle cost, all in at one check cost, using somebody else's money costs, all of those are factors.
Okay.
Go ahead, John.
Yes. I have a small house in Fairview. We did all the energy efficiency items and we sized our solar panels to our need. And so we're living within our need right now. But we're supplemented by the grid. So we're a grid hybrid. I think a real good idea is to be a grid hybrid to begin with. And as the source of the grid goes from coal to renewable energy, then you're going to be your 100% sustainable. But right at this point, we're in a transition time. We set ourselves up so that we use the grid to store our energy, and we use solar panels for solar energy plus a surplus. And then when we get an electric car, we store the extra energy in an electric car. But I suggest a hybrid, and you can allow the renewable energy coal plant to kick in one of these days and off grid solar panels or water or wind when it happens. That way you're in the position without being messed up in the beginning.
I think that solution lends itself to bringing the sustainability piece into the equation sooner, but I also think that drives the upfront cost up potentially unnecessarily.
Yeah, so when what Paul and Ryan have been talking about is kind of laying the framework for us exploring a couple different options to say what is the best scenario for us, short-term, long-term, bringing in these factors that we talk about, and wanting to make sure that we fully explore both of these options to see what's best for the affordability of the community long-term and resiliency of the community long-term. So there's probably not an easy binary answer, right? Of like, we get down to the end of this, it's gonna be like, you're right. This is the solution. We know it. I think it's going to take iterations of us sort of exploring this, figuring out costs. And so that's what we're sort of all of these teams are sort of driving for is getting to us to a point where we kind of understand what the different options we need to start weighing on, as opposed to starting out with everything's on the table, so we can just think about everything. You know, we now are getting to the point where we understand that we have maybe 2 or 3 options related to producing energy for this site. And now we can spend time really digging into that.
Well, and I think, so just step back to last week, and correct me if I missed something you said, Virginia, but the upgrade to the airport substation. And then that gets you to 40 megawatts, about. Above that, then we have to go back to the connection with Excel, which is an additional cost. So I think one of the reasons the hybrid and the kind of the stuff that we're talking about is on the table still is, as we maybe try to stretch that 40 megawatts out as far as possible, you know, can some of these other things we're talking about help us? And the piece we're missing right now is the demand, right?
Yeah.
If it's under 40 megawatts, then we're.
That's
Yeah, and that's, well, I guess my thing that I would go back to with the 40 megawatts is, you know, what we were anticipating. Again, it's so dependent on the type of housing you
Right.
guys are, the actual usage. But I mean, you know, we were estimating that to be right around 3,000 houses. So if you have a desire to build 4,000 houses, then you really need to look at how can we get that down. If the desire is to build 3,000 houses or 2,500, then we really aren't as pressured to try to figure out those alternative ways to get that.
And I think a really interesting point in Paul's presentation last time is he showed us what it looks like if it's an all-electric home,
Right.
all-electric heating. So if we went with a geothermal heating system, would that mean well, how would that affect? Can we mean that max demand is probably less, and then that big infrastructure cost could be lower, or we could serve more people or more homes?
Serve more people, not trigger the upgrades needed beyond the
Sure.
substation.
So potentially, even though we might all want all electric homes, maybe that solution is to use geothermal for the heating to keep that demand down and combine the system that way.
Yeah, and there could be some hard choices, you know, we could bring natural gas back into the conversation, which doesn't mean sustainability goals.
Right.
But cut your heating, you know, cut your energy demand in half, essentially, say heating is half your demand. Then that electric capacity gets stretched a lot further.
Or build in a lot of load control, you know, like I mentioned last
Yeah,
time, building smart homes that have
Or-
load control ability, and that helps.
Yeah, and that's how we get into future individual building systems.
Yes.
You know, you could say, if we commit to Virginia that we're gonna build these really efficient homes right now, and then 5 years from now, we're gonna build the homes, and the cost to build those really efficient
Right.
homes is twice what we thought it was. We've made a commitment we can't live up to.
And for me, it boils down to the National Electric Code. So back when I was a utility planner, we asked our clients, give me your neck sheet, right? How many amps is this place gonna draw according to the form that the code requires? And so I just want to make sure if that's gonna be the driver, and I recognize the study you guys did, I did those too. Homes never hit what that little sheet says they will, because it's this one's for safety and this one's reality. So what I heard last time as well, if we come in and the homes are, NEC says they're 30 amp, 30 kW homes, and reality says they're only gonna be 20, are you gonna size your system for what the paper says, or what your history of managing the grid says? Because that's another key driver on your sizing and your KVA sizing all the way back to Sarah's point.
We were basing the sizing that I gave last week on our historical data of homes in this area that we're actually seeing usages. So, I mean, yes, we have to size appropriately for what it says it will use, but we also take into consideration the data that we actually see.
I appreciate your expertise. This is a topic we're not done talking about, but we might need to be done today because Ryan has some issues that he wants to present. And I want to get through, I did 5 slides, I want to talk about 5 slides today. So, but anyway, it's a good discussion on, as was.
Jason, it seems like we take this information, we have the technical experts help us figure out what's maybe feasible. And then the economic people help us figure out what's affordable.
Yeah.
And then somebody makes some hard decisions. Is there anything else you think we need to talk about today?
I think, not today. I think we're fine on that. I think but just projecting, we're gonna need to get some good cost numbers. And so that means Virginia needs to know how many units we're building.
And how big they're gonna be.
And how big they're gonna be, yeah. Well,
And how energy efficient.
you're correct, and so other teams are working on that. Like at the economics and urban design teams, we're talking about how are we developing this community, what product types, what, what are the other kind of spaces that we're trying to make room for as far as like schools and daycares and grocery stores and those types of things. So ideally, we can get a high level number for you all to start planning off of, even if it's maybe 3 different scenarios of build out of different product types or maybe different mixtures of housing, densities and things like that. We all understand that we have to work towards getting some specificity to this so that we can answer all of these questions, because the folks from the city are on wondering the same question as it relates to water. And wastewater and all of that. So
You'll need those same answers too inside the microgrid, right? If one of the options is completely off-grid, self-sustaining, we build our own power right here, they'll need those same questions to be able to put a price tag on that as well.
yeah. So we're gonna be getting to a point where we have these probably 3 build out scenarios that we can start putting numbers to. Maybe it has 3 different types of units versus, for water consumption and for electric consumption.
So let's go from the technical to the fun. The other thing I was asked to do for this presentation, if you want to flip a slide on me. So there we go. So what precedent projects could be considered as a model for Brown Ranch? This is Whisper Valley, Texas. Slightly different climate, not quite as cold, but definitely hotter. So just kind of flip the demand. They have to have a lot of air conditioning load. We have to have a lot of heating load. This is a planned 7,000, it's under construction and units have been occupied now. 7,500 single family, multifamily housings in a planned community. It's a developer-based community, so it's not like this where a housing authority is putting it in. They did go with what they call the geogrid, so those homes and commercial office spaces are all connected with a common water loop. And they're figuring 70% reduction in energy consumption by doing that from what they would have had with a traditional heat pump system for heating and air conditioning. And those systems actually are what we call triple function units. So the heat pump provides space heating, space cooling, and domestic hot water. And then all of that goes into a common loop. They went with all Energy Star appliances. They've given people the option to put solar on their individual roofs. So they're what we call solar ready, where the conduits are in place, the developer's not putting solar on the roofs. They call it an energy monitoring system, so folks can see where their energy use is going and maybe take active measures. But I would say for our purposes, that could become an energy management system. So don't run the dryer if the heat pump's running, or don't run the dryer if the car's charged, or don't charge the car while it's 20 below zero and everybody's here cooking turkeys for Thanksgiving dinner. Every garage has an EV charger in it. So they would be Colorado compliant for the 95% of registered vehicles having EV charging. They're also plumbing these houses so folks can put their own batteries in. So they have an option, so they're pre-wired for battery storage on a unit by unit basis, not a community basis. And then they're going for a high performance shell. So they're going for a HERS rating. HERS is the home energy rating system. To kind of just briefly, in this community, a HERS score of about 80 says you're meeting the construction code, and a HERS score of 25 says you're maybe 25% better than code in your building shell and performance. So they're shooting for a HERS score of 25 or less because that HERS score and their climate would let the folks who put PV on the roofs get to what they call net zero over the annual energy cycle. So I've got the links up here if you want to noodle through that, but that's a community that's doing all the things that we're considering. Super efficient, smart home with EV charging, with a community loop, with a heat pump based system for all thermal loads.
Great. I think that's a good one. It kind of goes back to Brooks's idea about looking at some of these pieces as part of our idea to get to that long-term cost of using electricity for the long run. So that's really good stuff.
And that's the kind of energy savings I've been seeing on other projects that have gone to a thermal master system like Ball State University. I mean, they knocked out $5 million a year in energy usage.
And Colorado Mesa, just a couple 3 hours from here, is probably 90% intertide. And the last, I just talked to the engineer and did the design work on that. I was on a call with them this morning. They still haven't fired a boiler in 5 years, and they doubled the campus size.
Also put in a wind farm in Hayes, Kansas at the university there. And when we were debating the various sources of putting up the tower and the generation, we made it such as that if anything ever went wrong in a lifetime, that the company would replace it in a good thing, because we lost the generator. And they had to come in and replace it. But basically, it saved the campus $500,000 a year in energy costs. And it went completely self-contained on their total campus energy without doing anything else but just putting in 2 wind farms. We don't get enough wind here.
No, we don't.
You know, so I'm not sure that it's worth looking into that here.
So this is just kind of a capstone slide for the discussions we've had this afternoon and last week. So kind of a rough estimate, I think, Ryan, this is your numbers, you can change it if I put it down wrong. Like $25,000 a lot for standard utilities, right? So that's a check that has to be written into the system to make that happen. That includes water, electric, TV, internet, phone. We don't have the granular costs. If you're going to do a interconnected thermal system, there's what we call joint trenching opportunities, where you dig one trench and you put 2 services in, so you only have to pay the excavating cost once, and you can leverage that first cost between multiple services. And then there's again, as I mentioned earlier, we really need to be granular on what's it cost to get power to Brown Ranch, and then what's it cost to distribute power throughout Brown Ranch. So I break that into delivery versus the development distribution. And then, as we just mentioned, we still got to do a lot of work. If you can't get to where you need to go and where YBA needs us to be, till we know the building types, which is both the residential and the commercial, because commercial is going to eat into that 40 megawatt load as well. And then that's why the efficiency, I think, has become pretty important. Once you know you've got a cap, how can you come in under that cap? And then what's the timing? So you've heard from Virginia last week that transformers don't just show up on the UPS truck after you place your order on Amazon. So they need to have their timing and their decision points. They have to get to the site. So that might include right-of-way acquisition and buried conduits and all that kind of stuff. So that timing is important. And then are we going to have 1 access point, 2 access points, and then are they where the people live going to be by where the power lines touch the property, or then you have to, how far do you have to dip to get from there? And then that current versus future costs. So we know what things cost today. We're not going to break ground for 3 years. So is a battery 3 years from now going to be more expensive or less expensive for kilowatt hour stored than one today? The indicators are storage prices are going down. Right now, PV prices have kicked back up because of tariffs and supply chains and that kind of thing. So you need to look at all of those costs. And then non-traditional services, the whole microgrid concept is coming out of the gates fast. So the more players and the more demonstration projects, and those price points are gonna change. So those are all, I'll just put those out there because those are all the things that we need to granulate.
Ryan, I'm guessing those costs are exclusive of impact fees. Those are
Yes.
strictly construction and materials and labor.
And those are just, yeah, there's other numbers too, so
It's just to get the stuff in the ground and
to your, no, just to your, from the.
Other tap fees and stuff, right?
No,
Well, that's the service drop to the house, right? That's
Yeah.
gotta put your transformer on the curb, and then you still gotta get to your footprint.
yeah, and then that also excludes like your water and sewer mains, they're gonna actually be in the roadway. Your storm sewer, so. That number 25,000, I would say that's probably more just your dry utilities.
That's the word, yeah, dry utilities.
I think Ed McConnell said sunlight was 125,000. They
That's,
could get for the pool permit.
yeah. So that number's, we can develop a cost, I can develop some cost for you for the final meeting, I think.
Yeah, well, as in a lot of this preliminary, they're very nuanced, you kind of gotta know it all before you come up with that.
Yeah, and the other thing is, per lot, costs can be very deceiving, right? Because
Sure.
And if you have 4,000 lots, you're dividing these huge initial costs by 4,000. It's all the same initial cost for 400 lots.
And then, yeah, just to reiterate, if we come in with whatever the plan is under 40 megawatts, then you're good. But then if we'll know you're at 48, how much is that extra 8 gonna cost? Because if that's multi-millions of dollars and something, oh, those windows look really cheap, right? So that's why we really need that. What happens if we don't hit 40 megawatts? What is that next price point? It's gonna be a key decision factor, I believe.
Thanks, Paul. This is eye-opening, confusing for me, but pretty critical. Pretty high on the priority list, I think. Now that we kind of know what we're looking at.
Ryan, do you wanna?
Yeah, we'll go
Some
into
stormwater, please.
stormwater is a little bit more straightforward.
It goes downhill, right?
Yes.
Hopefully. Or into your basement.
And also,
Or to your basement.
Or you're using a pump.
Or your pump,
I think we can also, this will be one that we can push some of the heavy lifting up to some of the other groups, but especially the urban design group. That'll be maybe nice while we focus on the review.
Right before you start, there's certain city regulations. We can't just kind of go off, do our own thing here. You're gonna have to follow some fairly strict guidelines. Is that accurate?
Yep, so I'm assuming that this parcel would be annexed into the city, and we'd have to conform to the city's regulations. But above and beyond that, there's also Colorado state law and Round County regulations, which would require a lot of the same things that the city would.
When you say state, are you talking water quality and water rights issues?
More water quality and then conveyance issues. So, essentially the way the state law reads is you have the right without an easement to discharge stormwater onto a downstream property at the existing rate. We're going to historic rate, yep. So when you come in and pave a whole site, you can't just let all that water run off on your neighbor's property. We'll get into that a little bit more. So just first, and I'll try and run through these.
We have about 40 minutes.
Just to orient everyone, we're talking Brown Ranch here. Slate Creek is the major drainage way that runs kind of through the spine of the site. There's a secondary drainage way on the west side that I'm not really going to talk too much about today, but everything I talk about for Slate Creek applies to that same basin. This is from the Steamboat 700 annexation application. It's a floodplain study that was submitted for that project. And this is the USGS map. Down here's Brown Ranch. This red line here is US 40. There's the airport runway you can see. And this is Route County Road 129. So Slate Creek, actually, the basin for that extends to the east side of Route County Road 129 and up Copper Ridge. This is Copper Ridge right here. It's about 3.36 square miles. It drains down through Brown Ranch. So when they looked at that, they calculated a 100-year flood flow of 150 cubic feet per second. So a 100-year flood flow, that's a flow that has a 1% chance of occurring in any given year. It's a little misleading the way it's the terminology for it, but if you actually, set up your tent out there or your house for 100 years, you actually only have a 63% chance of seeing this flow. But so it's in any given year, you have a 1% chance, and you could have it in multiple years. You could have 100-year flow in 2 years throughout. The probability is highly unlikely, but so looking at that, what they determined as part of the Steamboat 700 project is largely that flow of 155 CFS was confined to the Slate Creek channel. There is some flooding down at the Highway 40 culvert that goes down between KOA and Sleepy Bear. But that flooding is largely, so the capacity of a culvert is, as you increase the head or the amount of water above the top of the pipe, you increase the pressure and more water can flow through that culvert. So the flooding you're seeing there is a result of water backing up. Once it gets to a certain elevation, there's enough pressure to push that 155 CFS through. So this flooding could largely be mitigated by just filling the area around there, because you would still have the same water surface elevation. You would just minimize the extent of that.
Is there potential for the underpass for the core trail to include some sort of conduit?
There isn't. I'll get to that in a minute. It's a good question. So what happens? This is from the urban. This is a slide from the urban design group. So right now we have, the site is basically in 100% pervious condition. There's a few gravel roads out there, but for the most part, it's undeveloped. The urban design group has started looking at how much of the site, 534 acres that the project could develop. They start to take out the portion that's outside the urban growth boundary, areas along the creek where the slopes are too steep, and they're left with 324 acres.
Is that portion outside of the boundary truly, should it be taken out of the building calculations that we're making?
That's one thing the urban design group's looking at.
Okay.
Yeah.
It seems to me like the border is just a random dot somewhere that it could be extended. But okay, so someone's looking at that. Okay. So that number could increase.
It could increase, yeah. Okay. That's just for
great
for this discussion. So and then they started to map out kind of areas that could be developed. This is how you come up with 324 acres. So what happens when we go in and start developing all that? So what this slide here is showing is in its natural state, about 5% of the water runs off and 95% soaks into the ground. We go in, we start putting roads, sidewalks, parking, buildings. All of a sudden we flip that equation. 95% starts to run off and 5% starts to infiltrate. So this has a few different impacts. We increase the amount of runoff significantly, and then also we decrease water. So as you start to develop, or decrease water quality, as you start to develop, pave things, put buildings in, there's a lot of scoria right now is the best example. We spent all winter putting down scoria, and now it's all getting washed down into the road. So we have to deal with these impacts that development creates. When we increase runoff, we have two choices. We can either increase conveyance capacity, meaning we put in more pipes, more inlets, we enlarge channels, or we have to detain and limit flow to the existing release rate, so that 155 CFS.
Ryan, that's a pond. Catches it, and then there's a controlled outlet that
Yep.
releases it at the historical.
Yep. And then for a decrease in water quality, we'll have to construct what are called permanent stormwater quality features. And I'll go through some examples of these, but basically these are things that try to catch that sediment, try to catch floatables, so like styrofoam, stuff that floats to the top, sediment goes to the bottom. And then there's also lots of chemicals and runoff, you know, from our cars and our fertilizer and the things we just use in everyday life.
Ice melt.
Yep. So when we start to talk about conveyance, when we're looking at Slate Creek, it comes down the spine of the site and then it goes into a 60-inch culvert under Highway 40. This is a picture looking down that culvert. And then it discharges into a swale that runs between Sleepy Bear and KOA. And then flows down to the river. This is a picture looking down that swale. So you can see this right here does not have a lot of conveyance capacity. It is heavily landscaped. It's, you know, both properties have basically developed right up to, you know, basically each side of the channel. So there's about 20 feet. This culvert under Highway 40 is limited by the elevation on this downstream side. You know, we can't lower it and make it taller, wider, because it's, well, we could potentially make it wider.
That grade is set.
But that grade is set, yeah. And then if we start to make it wider, you know, we could put in, like, let's say we put in 3 of these 16-inch culverts, you know. How does this downstream channel handle that flow? Well, it doesn't. We start to look at flooding the downstream properties. There's not an easement down there. There's so again, we go back to state law that you guys have the existing, you have the right to discharge an existing right. But to actually go in and improve this channel and increase conveyance down to the Amber River would require agreement from those property owners. So I think, you know, the Overlook project, Steamboat 700 and Steamboat West neighborhoods all came to the conclusion that conveyance is not the answer to handling the increasing runoff. And they start to look at detention. So just running some quick calculations. If we assume that 330 acres are developed and we take the imperviousness from 5% to 75%, we start to look at some required detention volumes. So city code requires you to look at what's called the minor storm. So a 5-year storm or a storm that has a 20% chance of happening, and then a 100-year. And so the detention required to handle that increase in runoff is 17 acre-feet or 30 acre-feet for a 100-year storm. An acre-foot is a body of water that's 1 acre in area and 1 foot deep.
So through the football field is about an acre. You know, a football field a foot deep is kind of
Probably,
a visual of what an acre.
Yeah.
The volume of an acre.
Yeah. You can see, I mean, these cubic feet numbers are pretty large and they're kind of hard to visualize. So that's why engineers tend to talk in acre feet.
And it's, need to be clear, it's not acres, it's a volume of water detained within a pond of so many acres and the water is so deep.
Yeah. So if the water was only 1 foot deep, it would have to be 30 acres. If you had it 5 feet deep, then it would only be 6 acres. The city of Steamboat Springs does require regional detention for new subdivisions. And the thought behind that is that they want to try and minimize the number of detention ponds. So some municipalities will let you have detention on a lot by lot basis. A lot of places in Steamboat now, where detention wasn't really a consideration, even up to 5 years ago. Now we're having to implement detention on a lot by lot basis. It tends to be very inefficient, and it's also difficult for the city to monitor and keep an eye on. So their code requires regional detention. They don't really specify what regional detention means. You know, it doesn't talk about whether it's one large feature or multiple features. It doesn't go into what a 5-year project would look like.
And Ryan, can it be multi-use? You know,
As far as
can you put a soccer field?
Yep.
Regional detention pond?
And that's where I think we could start to push some of this heavy lifting onto the urban designer to say, well, here's the 30 acre feet we need. You guys figure out how to incorporate it into the site and make it useful. And, you know, like I said, if you moved into Brown Ranch and lived there for 100 years, there's only a 60% chance you would ever see that pond full to that extent. So 99% of the time, it could be used for something else, whether that's active or passive open space. Looking at water quality capture volume. So that's as we start to figure out how much water we would need to treat to collect those pollutants and or to remove those pollutants. Some quick calculations say that that has to be 9 acre feet. And that can be combined with detention. So the city of Steamboat does allow you to do that. Some cities don't allow you to do that and require it to be separate.
Ryan, what's the size of the ponds on this site?
Good question.
Like in
There's a
relation to-
stock pond out there, yeah.
Yeah,
Yeah, that's a great question.
is that a 9 acre foot pond? Is it a
Yeah.
8 acre, 12? I don't know. It's pretty big.
It is, yeah.
It's probably an acre at least.
So now I'm going to start to talk about some stormwater solutions. So number one solution, whatever you can do to reduce the runoff. Just minimize the amount of water that we have to deal with. So the less pervious the site, or impervious the site, the more pervious it is, the easier it's going to be for us to deal with all that.
Ryan, you can't actually stop it from raining. What you're talking about is reducing the rate of runoff. The total volume never changes.
Well, the volume would change if in like these two scenarios, you know, if you can, for instance, let's say that as part of the project, people are going to walk more. So we can get rid of half the cars, or we can cut the parking lot size in half.
So you've increased
Pervious
area.
decreased impervious.
Yeah,
More
you said-
parks, less parking lots.
Less parking lots, yeah.
More gravel roads, less paved roads.
You said 75%, 75% impervious, is that like a typical?
That's a typical number, yeah. So, you know, it could be anywhere from 80, like downtown is probably 95. You know, I would say we see anywhere from 65 to 95. Kind of on the lower sides, yeah. So the closer we can get to 65, the less stormwater runoff we're going to have.
Yeah, I did a subdivision as a planning commissioner back in Illinois, and they used a busted up concrete for all the sidewalks. So that it was pervious, you could still plow it, people would walk on it, and they could keep it level just by occasionally going in and taking care of those spots. I don't know if that works here because we don't really have a big source of busted up concrete.
Right.
That is one method, and there are, of course, a lot of others.
Yeah. And so that's really the overall strategy, is whatever we can do to increase.
At an
pervious
earlier
surfaces.
meeting, I heard the women from the Crane group, was it for CCCCs, anyway, they were concerned about having wetlands in the west portion of this property. And then across where you cross the Highway 40, they've got a very famous nest of a couple of the cranes that have been there for 10 years. And they're worried that we're going to do something to start that. That's where we had the Cameron baby chick last year. If we created a larger wetlands, would that just subtract from your detention requirement?
That's a good question. Let me get back to that one.
Okay.
So the other thing we have to do then when we start increasing the amount of runoff is how are we going to capture and convey it? And in Steamboat, there's two traditional methods. These are the city's standard street sections, two of the different street sections. On the left, you have curb and gutter and storm sewer. That's what this gray pipe here is, your storm sewer. So this is what you see downtown. On the right, you have an open swale. So that's what this little green spot here is. So the water runs off the road into the swale, and then the swale conveys it. That's what you tend to see in a lot of the outside downtown and some of the neighborhoods. The trade-off and benefits are that, you know, the curb and gutter costs more because you have to put in concrete, put in storm sewer. But it's more compact and it allows for denser development. So that's why you see it downtown. The swale open channel is less compact, but it also costs less. So that's why you tend to see it more in rural and residential areas.
But it decreases your developable area because you have to dedicate acres to the swales.
Yep. And that's, you can kind of, they're kind of showing that rudimentarily in these graphics where, you know, these houses are set back and it's less dense than this 3-story building. So as we start to talk about detention and then water quality, they're called BMPs, or best management practices. And there's a nonprofit organization in Denver, Mile High Flood Control District, that has developed a toolkit to help people address these impacts. And they have these different tools. And this is pretty much the Bible for drainage in Colorado. And so as we start to look at ones that would be appropriate for Brown Ranch, there's some that we can rule out probably right off the bat. Like, for instance, green roofs tend to not be very practical in soil climate. They're also very expensive. Sand filters that's kind of your classic old school detention pond, just a giant pond with nothing in it. It's kind of an eyesore. And the urban design group already crossed that one off. So. There's retention ponds, constructed wetlands ponds, and wetlands channels, which is what you were talking about. The major challenge that we would have with those is those require permanent water sources. And Slate Creek is not a permanent water source. It's seasonal. And there are times of the year when it dries out.
Ryan, why do you need a permanent to keep the cattails growing?
Yeah. So a retention pond, that means it has water in it all the time. And then the wetlands, they can be extremely hard to establish and maintain. Source, it may in fact be impossible.
One of the things I hope we're going to look at is.
Hey, Ryan.
Yeah.
This is just had some discussion about this in the sustainability group. I would question that last column, the constructed wetland channel. I think there are feasibility to sustain riparian vegetation beyond what's there now with some, which would also benefit conveyance, because you would basically de-channelize Slate Creek rather than making it a flashy, ephemeral, slow down the water, which would probably get you enough groundwater to sustain some riparian vegetation. So how much of a benefit that would have, I don't know, but I would completely cross that off the list. The others, perhaps anything that's a pond, more likely.
Yeah. Okay.
The other thing is that I believe Leonard Rice will look at the feasibility of raw water irrigation for turf with some fairly cheap water, treated effluent, right on the river, ag water out of Stagecoach. That water didn't cost very much, so I hope that we can put a pencil to that and see if it makes sense. That might be a source to establish some of that.
Yeah, and then wetlands can mean different things to different people. The Army Corps of Engineers has a definition of regulatory wetlands. You can have riparian vegetation, which actually probably falls in some of these other categories too. But as far as Mile High Drainage defines a constructed wetland, it's probably not a great choice for Brown Ranch. So that leaves us with these 5: grass swale, grass buffer, retention or rain garden, extended detention basin, and permeable pavement. And so these are some pictures of what these start to look like. You know, a grass swale is really just a drainage swale, like I showed you in that section, but it's lined with vegetation. Vegetation removes sediment, it's uptake some of the pollutants. Same with the grass buffer. The difference between a grass swale and a grass buffer is a grass swale collects water and conveys it in a channelized form. A grass buffer has just sheet flow across it. So it's not channelized. A lot of times they're used in combination. A rain garden is just a landscaped area that's designed to flood during rainstorms. It's more of like a depression than an actual pond. And then here you start to see what a large extended detention basin can look like. This is where we talked about, you know, trying to incorporate it into active and passive open space. So in a major storm event, everywhere you see grass or water, but the rest of the time it's just looks like open space and their kids can run around with it. And this is called a low flow channel here, down here at the bottom. So that's where the majority of the time where the water is. And this is a highly constructed one, you know, we see the concrete channel, you know, it can be more naturalized like in the same.
So with our snow removal challenges, how do these integrate into the issues associated with snow removal and storage?
Well, they're all great for treatment. The snow removal does increase the maintenance we have. And that's really effect of the scoria and debris and everything that gets plowed into them over the course of the winter. So when the snow melts, you know, if you've ever like think about the pile of Old Town Hot Springs, you know, when that melts, they have to go out there and clean all that up in the spring. And it's going to be the same with all these, you know, the end of the spring, you know, this grass buffer here has to come in and be raked and all that scoria and debris has to be removed. You know, permeable pavement is just pavement, like Brooks was talking about, that allows water to flow through it. In this example here, you can see these concrete blocks, they're hollow, and there's just sand in the middle. It's a great tool, it does tend to be more expensive.
Does the city allow it?
City does not allow it in the right of way, but it could be something that could be used on private property. Here's some more examples of these just implemented. So here's these are rain gardens, just, you know, included on the sides of streets. Here's some stormwater swales, and then this is some examples of open space where detention's been incorporated. And again, in these two examples, these would all flood in the storm event. This would be underwater. So this is a graphic from Link. It's when they were master planning Rhino. On the right, this is sort of the conventional water quality low impact design features where you have individual lots that are carved up, and then as developers come in piece by piece, they have to construct these ponds. And as part of this Rhino plan, what they worked with the city of Denver to do was incorporate all that into a linear fashion along the right of way. And so what that allowed them to do was increase density by 25% and reduce their construction costs by 25%. And the reason they were able to do this is because they were master planning this whole area at once and get the city to buy into their solution. This is a zoomed in detail of what they proposed there. So, you know, they had the traditional curb and gutter and then the sidewalk, but in between these were, just think of them as really long rain gardens or detention basins that provide both water quality and detention.
How wide would that typically be?
They're showing an 80-foot right of way here. I think these were like 8 to 10 feet.
The sidewalk behind it.
6 feet.
And a traditional right of way might be 60 feet.
Steamboat's anywhere from 68 to 80. So, you know, if we flipped back to this graphic here, you know, what they did is they took this area here that was traditionally, you know, like if you look outside, you know, we have bricks and pavers, and tree grades. They basically took that area out, depressed it, and made detention water quality feature. But still we're able to keep it landscape, so still kind of achieve that same urban design feel, but also create detention on a very long linear basis.
And increase density by 25%.
Yeah, that's what their estimate was, so that's.
Seems a little counterintuitive, but we needed more land for the swales.
So here what they're showing is like this, you know, they kind of took all this wasted space along the sidewalks, I don't know if it's wasted, but
Not used for storm drainage.
not used for storm drainage. And took these ponds, where instead of having ponds, and then put them here in a linear fashion.
Okay, so linear is more efficient.
Well, that's just one example of how they were able to do something on a master plan level that you could not do on an individual basis.
And I think that the purpose is to increase land utilization for us. So the more that we can double or triple up uses within a space, so we have areas that are open space corridors like what you've shown, can those serve as stormwater quality features as well, so we don't have to have them all in their own separate space. They can double or triple up on the same acre. So now you can utilize that space where those ponds might have been for houses. And now we've become more efficient.
And the efficiency you gain is not only on the stormwater side, right? Because you're still constructing the same linear feet of road and water main, sewer main. But if you're able to serve 25% more units, that cost per unit for all that other infrastructure starts to go down.
I can kind of see that on a grid. I don't know if we're gonna have a grid out there because of.
Well, and this
slopes.
is, yeah, I mean, what I was trying to show here is not necessarily the concept for Brown Ranch, but the efficiency that can be gained and the real innovation that I think potential with this project is to incorporate stormwater and think about it now. And have the urban design group really focus on incorporating it into their plan. And try to take double credit for things like Jason was saying, instead of addressing it down the road.
And so hypothetically, in our situation, I get we're maximizing land use. You have some numbers around how much stormwater we're gonna have.
Yeah.
Do those two currently match up with our hypothetical, say 3,000 homes, units? Or do we need to find better efficiencies to get there?
I don't know the answer yet.
Because maybe it's kind of maybe we could do any of those with the amount of land we have possibly and still get the homes. I don't know if we're tight or not.
Yeah, that's kind of until we start to get the demand.
Yeah.
And start to bring everything together.
Okay.
And this is just another example that's maybe a little bit more applicable to a fully integrated approach. You know, so this is again down in Denver, but you know, if you imagine this as Slate Creek here, where they have you know, riparian area and wetland area that's providing water quality and treatment. They're doing infiltration and water quality here in the roadway to try and reduce the runoff. And then, you know, here's your 100-year flood elevation, maybe in some sort of detention basin that is also part of Slate Creek or the open space around Slate Creek.
Ryan, how much do we have to plan for some of these adjacent parcels that are within the urban growth area but not yet annexed or even planned? Is it our responsibility to do some estimates and make sure our channels are large enough to accommodate neighbors?
I'm sure they would appreciate if you did that, but it's again, so we go back to that state law, you're only required to convey what their existing runoff is. So for instance, the Overlook subdivision, they're doing on-site detention to limit their runoff to historic rates that comes on Brown Ranch. So we have to account for it in the sense that we have to take into account the existing runoff from the adjacent properties. But we don't necessarily have to assume that they're going to be developed to 75%.
As long as they release at that historic rate,
Yeah.
we can accommodate it.
Yep. Which they're required to, but not. So again, you know, with all the things we talked about, this is oversimplified, very complex thing. But at a high level, I think that really the tools that are going to be used for detention and water quality treatment are really, the toolbox is pretty well fixed. There's not a whole lot of innovative ideas out there. But I think the one area for innovation in this project is to incorporate it right from the get-go.
Seems like we can fairly easily identify which of these technologies meet our objective of utilizing every square foot to build houses. That's our mission.
Yeah.
And if there's some that don't accomplish that, then we'll obviously led that one direction. But we brought them together a little matrix and saying this technology will accomplish this and this will accomplish that. Which ones of these are most important to you? And hopefully it falls out. If it's not too expensive.
Yeah.
That's the caveat, I think, with everything.
And we have, you know, we have been working with the design group. And so they've incorporated some of these slides into their presentation as well.
We should open it up. We've got people online and people here in the room that might have some questions or comments. Thanks, Ryan. That was informative. I thought I knew about stormwater.
Wow.
I don't.
Can I just to chip in because Ryan, you were right, Ryan, that you were incorporating what I was talking about into a different approach. This vision, what you've got right here on this slide, is exactly what we've been talking about in the sustainability group of both killing two birds, not to be negative, with one stone, and improving an environmental amenity and an open space amenity, meaning the Slate Creek corridor, and dealing with a stormwater management problem. So thinking holistically about improving the environmental conditions of Slate Creek and improving riparian function in particular, which has amenity value and ecological value, as also a way to help manage stormwater. So I think there's a lot of potential there, and how to integrate exactly in this kind of direction is exactly what we've been noodling around.
Those chats, and we have anything in comment that are,
It was basically what Tim just said.
great. Any other, Dylan, Catherine Brooks, anything else to put on top of this, or? Okay. I do really like the idea of, one thing I'm hearing you say is we have to sort of construct and build to this, but it's probably never going to happen, or very, very unlikely to happen frequently at least. And I like this aspect of, hey, a soccer field that's able to use the soccer field for 99% of the time, and hey, the day that it's wet, we don't have a soccer game. So that seems like a good use of the piece of land for sure. I do want to give everybody that's attached here an update on the next meetings. So the next meeting will be on the 17th. It is at noon in a combination with the sustainability focus team in this location here. Then on the 23rd of March, it will be, so a change from what others may have previously seen.
Yep.
It will be at 5:30 p.m. in a combo setting with the urban design group. Jason, can you tell me that location?
Yeah, that'll be at the community center.
Community center.
Yep.
West Room.
I believe it's in the West Room.
That's at 5:30, not 5.
Yeah, so we have the 17th at noon with the sustainability, a combo meeting. And then the 23rd at 5:30 in a combo with urban design at the community center.
Yeah, and these teams are starting to weave together because you just can't get away from the fact that these are interrelated. And so I think we've done a very good job of focusing in on our own particular topics, but we've gotten to the point where we really need to start integrating these conversations because as Tim had mentioned, they're having the same conversation about stormwater, but let's have it all together, right? And so and the same thing is true as it relates to economics and demand, stewardship, as it relates to energy and infrastructure, sustainability. All of those things are starting to weave together, which is kind of how we saw it all going eventually. You can't remain in silos forever.
And Jason, are you going to give us a document that shows these interrelated activities? Are we gonna have to remember when we show up at the meeting today? The stormwater thing kind of spills over into this. Do you have a pretty good handle on
We do,
what
yeah.
the issues are and whose realm?
Yeah, so
exist in?
we've actually got some framework stuff that our prime consultant with him has been working on that would help identify the kind of who's the lead and who's the support in these particular areas, knowing that they're all sort of integrated.
Any other comments? Give everybody 5 minutes back today. Thank you very much. And appreciate everybody's input and involvement. Ryan, thank you very much. Paul, thank you. Really good stuff. And I agree with Jason in that comment about bringing these teams together, because I think what we can start to do now is as these teams come together, I think we today knocked out a few things. Okay, this won't work. When we bring the teams together, the teams can also start to say, okay, this isn't going to work for us. So
Yeah, we're headed to that area where we're going to identify where the synergies exist. You know, we just talked about urban design and stormwater management and all that stuff kind of maybe working really well together. We're also going to identify areas where we got some conflict that we have to figure out. Right. And so as we start integrating, we're going to see that, man, these things are great. This is working really well. Let's continue down that road. We've got to maybe pop it up to the steering committee to deal with some of these things that maybe don't have that synergistic relationship, that have that sort of competing relationship.
yeah.
Maybe before we depart, we should ask Public Works. John, you've suffered through this. You always have some insight. Do you have anything to share with us that might help us in this process?
Sure. Well, I think Ryan's presentation was very good. He's worked a lot in the city and he's worked at other jurisdictions as well. So I would just encourage everybody, follow Ryan's lead. He's got a good handle on this, and I agree with everything he said today.
Thanks, John.
Glowing endorsement.
Yeah.
Morty, you got anything nice to say about him?
Like to see.
I would second what John has to say. It's utmost importance, and when you look at Ryan gave some good examples that you can really take some of those areas and put them and plant them with drought tolerant plants and make them look really attractive and the like. But yeah, Ryan covered all the bases really well.
Thank you. Everybody have a great rest of your day. Thank you all.
So I can